So welcome back to another episode of KJet. Now, RS Turbo units, one of my favourite cars. I know I love Mark II Golf, but growing up the year we did an RS Turbo, what a car. I've done a few of these at the moment, and off one of my last videos, someone asked whether I could do a setup on an RS Turbo unit, so here we are, not this one up there. Now, this type of air meter is probably the hardest one to set up. And also the RS Turbo units are one of the hardest ones to get running on a car. Not because of the fuel distributor. 75% of the time it's not the distributor at fault. It is either this at fault, the electrical read feeding to it, or the pot sensor, or air leaks, or a number of electrical problems on an RS Turbo. You've got so many things. There's like 3 coolant sensors, one is just for fuel. You know, you've got so many different things in it. So if you have got problems with your RS Turbo and someone's saying your meter in head, take a few steps back. There's probably something else going wrong with it. I had one recently. Someone said they can unplug the EHA actuator. This is pretty much a warm-up regulator, but for kjetronic. They unplugged that. Car was perfect, idle, lovely, boosted, everything. Plug it back in. There's a fault, and they wanted the meter in head reconditioned. You know, I'm not in the position of going, okay, I'll do it because I want money out of it. Because if I was to take it on and do it, nice and clean, put it back in the car, same faults there, I get the blame. So, you know, there's lots of other things can go wrong with RS Turbo units. So, let's dive into setting the air plate. It's very different from KJet, and a lot of KE units, like the other videos I've done on KEs, this is a downdraft, and you've got what's called an idle path, and it's very big. So let's move on to that, and we'll show you what we need to set. So here we are. This is the air meter. You can do this on the car because you need to do it on the car because you need fuel pressure in it to follow the measurements. Obviously, we can mimic that on here because we're on the test rig. So first thing, get your arm off here, a couple of Torx bits, because you need to measure from the top of there. So first thing we will tell you is we have a longer cylindrical point. So this bit here, bottom corner of my ruler there, down to this bit here. This is an idle path. Now this is about 4 mil, and a KJet one is about 1 mil. So we've got a lot of movement in here we need to set right. So let's get firstly the basic setting, or the basic position. So as we see, the plate's here, just flopping around, there's no pressure in it. The basic position is, see the line there, you've got an opening gap, it's got bigger, it's got smaller. Now you just see the pin, the lowest point of the cylindrical funnel. Right, that is the plate at basic position. You move it too high, disappears, too low and you open a gap. So basic position is right there, which is this air plate is bang in line, flush with the lower part of that cylindrical part, just there. So that's our basic position. We also have a zero position, which is about here. So there's a big gap there. So what we need to do with this off, we need to get a depth gauge on top of there and measure. So we've got on a depth gauge. Now what we need to do is find our basic position and mark it and measure from the top. So we want that bang in the middle of there, flat there. So, you know, you can move the plate and it moves the arrow. So let's zoom in and I'll locate basic position. Right, so we can see there the plate is opening, and that is not basic position. So basic position is just when that dark line disappears. Boosh. And then we want to lock off our caliper. So once we've got our measurement there, this one is measuring 22 millimeters. That is not a set measurement, that is just what this particular one measures. And now from the basic position, where the plate is, like say, flush with the top of the cone, to the zero position when it sits on the spring behind here, when it does its rest, needs to be between 4.2 and 4.4 mil. So from basic position there to rest on the spring needs to be 4.2 to 4.4. So we're at 22, so we need to be at 16 mil. So how do we set that, you ask? So little dowel down here with the blue highlighted on it, because that's the one you need to move. Don't do that one, do this one. Now this is an interference fit, so do not do this too many times, because if you wear out the pin and the interference fit, that won't move anymore. That will move too much and cause you problems. So to adjust it, literally tapping stick, give it a tap on there, gently, gently. As soon as you feel it move, measure. Now what we're measuring, so we know basic position is about there, and then from basic position to zero position, when it sits on that spring, needs to be 4.2 to 4.4 mil. So again, we've got 22 mil on our basic position, drop 4.2 mil off that is 16 mil. So we need to be minimum 16 mil, and we are literally on it. So we don't need to adjust this, which is good. But if you need to adjust it, knock that down, and if you need to put it the other way, there's a pin just there. You knock that up. Again, don't do it too many times, because once you wear out that surface, you're into a pain. The next thing we need to check, once we've got our base position and our zero position, that gap there, once that's set, we need to then switch fire to checking this gap. Now this bit here moves independent of this. Obviously this one won't, it's pretty seized, but turning that clockwise, so if you turn that in 0.1 of a mil, the effect it has on that plate is 0.7 of a mil. So you move that in a bit, that moves that a lot. So what we want to do, these should be where they are, they shouldn't really move, but you want the distance between there, measure that, write it down. It's not too drastic if you need to adjust that, but at the moment you shouldn't need to. But inside there is a seal. Actually, that seal, because that's the seal I've just taken out of this unit. Now what that does is when this plunger is at rest, it rests on that seal and seals it. Now what we don't want to do is have the air plate set to a point that when it's pressurized, that can't go down anymore, and it doesn't allow this to seat because you have a fuel leak. So the next thing we need to check is the distance between the air plate arm and the needle roller that sits under the fuel distributor, which sits on this. So how do we set that? I'll tell you. So you see a gap down there. There's got no pressure in the system. You know, if you're on a car, you need to turn your ignition on now and prime your fuel systems for a couple of seconds. So all I'm going to do is hold this down, not put any force in it. Watch that gap in there when I pressurize the fuel system. See, that gap's gone larger now. I'll zoom in a bit more so you can see. There we go, see the gap? No fuel pressure, pressurize it. See that movement? That is the movement we need to set next. So at the moment, this is held down, it's got a magnet on there, and the air plate is resting on the needle roller bearing, which is what we don't want. It needs to be a free play. So now I'll pressurize a fuel system, and like I say, it was moving the plate up. So we need to, that's on the roller, take a measurement, take this off, pressurize the system, and then take another measurement. Now you need no more than 2 mil and no little than 1 mil. So we're going to aim for 1 mil. So the place we want this to be sat, it's easier to explain it than show it sometimes. So that's our base position. Now what we want is when it pressurized for us to be able to push that plate down and it touch, you feel it touch the roller and it's barely broken that gap off. So we've broken the gap, we're flush with it, barely breaking it, and that's like 1 mil of move, and that's what you want. So you see we're too much there, so what we need to do is get 3 mil Allen key, So 3mm Allen key in the top of here. I've taken this, these normally have a tower on it. I've taken this tower off because this is pretty stiff and doesn't really turn the CO screw. So I've taken it off just for clarity to know what I'm turning. So to reduce that gap, we need to turn this clockwise, quarter of a turn. I've just turned it a quarter of a turn for the sake of it. To enlarge that gap, we turn it anti-clockwise. So what I'm going to do, I've turned it a quarter of a turn. I'm just going to pressurise it, and I want to be looking for that line to disappear. So I'm holding it down just so it's touching the roller, pressurise. You can feel this on your finger. The pressure's gone now, pressurise it, you can feel it push on your finger. Right, and we're just breaking the seal. So what we'll do again is another little tweak. Hold it again, pressurise. Nearly there. Hold it again, pressurise. Pretty much about there. I'll give it another little. So after numerous attempts using the Allen key, getting this right, pressurising on, off, we are happy with where we are now. So no pressure in the system. Pressurise it, full pressure, that goes up, and we've got a tiny line there. And then what we've got is, between it touching it now and base position, you've got 1mm of movement. So just zoom in so you can see that, because it is quite hard to see in other forms. So no pressure in the system. You see we've got quite a large gap there. Now pressurise it. There you go, full pressure's up there, and we've got a hairline line there, and we move that up, disappear, our base position on the roller, base position on the roller. So now we've got our plate sat where it should be, we need to check the potentiometer. So rest position on the roller, pressurised, you know, we've got 1mm of play between base position and then our base positions where it is to our zero position of 4.2mm. Once they are there, we then need to, like I say, set the potentiometer. Now, when this is at base position, we need between 0.2 and 0.3mm on there. Now, Ford has the reference is 8.5 volts, so between 0 and 8.5 volts is what we need. Maximum plate movement, so let's get some power in there. So we got our power in there. So we got 0.8 volts there, but I'm also just past base position. So we're going to hold that at base position. And we're at 0.3, which is fine. Try and zoom in on that with my eyeballs. Yeah, that's base position, so 0.37 volts. So you're not going to win any arguments trying to adjust that to 0.3. So let's say, yeah, so I'm taking that as 0.3, base position there, happy with that. And obviously when we move the plate further, you know, the voltage slowly goes up to, you know, it's 8.5 was the spec. And then we're bottomed out there, so 8.3. And if we need to adjust potentiometer, 4 bolts on there, loosen them off and adjust it to get it right. So there we go, that's another video. Like I say, if people make some comments in the videos, I'm happy to do things. I've got the opportunity to do it. If I can help you out doing it, more than happy to. So again, it does differ from the normal kjetronic with the like the Cardo 9As and all stuff like that. Terrible throat. So to recap, you got your air meter wherever it is. Your rest position is when it touches a spring at the top. From there, 4.2mm down, bop, needs to be where your base position is, which is literally just flush with that cylindrical point in the air meter. And then once it's pressurized, you want to be able to push the plate down so it's touching the roller. You can feel it. I know I'm talking, you feel it, but when you put your finger in and you pressurize it, you know exactly what I mean. So push the plate down when there's no pressure in it. You should just break that position of basic, and then when it's pressurized, that should bring the plate up bang on with your baseline. Now what that will do, it means that that's your idle path, is that section. So with kjetronic, the EHA on the side, which I still need to do the video because that one's cut in half, is your warm-up regulator. So relevant to where the air plate is, it dictates the lower chamber pressure, so it can change it, you know, for enrichment, cold start and all that sort of stuff. So if you get that plate absolutely bang where it should do when it's on its base position, as soon as that plate moves, the pins moving, fuel's going in, and it can do what it needs to do. And the potentiometer again needs to be on your base position, 0.2 to 0.3 volts. You know, if you've got 0 or, you know, 1 volt, you're already well off. So when the RS system uses that potentiometer range, you know, if it only uses, I think, mid-range potentially for whatever reason, if you're a volt off, it's just going to throw it all off. So there you go. It's quite simple, but that's the most complex one to get right, because you've got, you know, your 0 base, and then you need that free play, which is in a way contradicting. You think, well, I need it at base, the bottom of there, but then I need 1 mil gap between the roll on that, and it takes it past that. But you know, it's very precise. You get it in there. Escort units will put, even if they're slightly off, they will work. But we want to make things perfect how they should be from the factory. I'm not making this stuff up. This is all out, you know, workshop manuals from Ford RS ones, from Bosch ones. You know, you combine those together, they're all the same readings. Yeah, simple as that. Any other videos you want, like I say, smash them in the comments. I'm happy to, you know, if I've got the opportunity, happy to show you how to do it. And there we go. So if you've got an RS Turbo, you're very lucky, because they are amazing cars. And that's how to set the air plates on an RS Turbo. And I'll see you in the next video, when I should be getting on with Rossa's air meters, because that's all clean. These need cleaning. That's disgusting, so let's get that clean. Again, stick a like, hit subscribe, and I'll see you in the next one. Cheers for watching. Bye.